Okay, today we're going to look at lesson 2. We're going to use metric measurement and area models to represent tenths as fractions greater than 1 and decimal numbers. So for number 1, we're going to for each length given below, we're going to draw a line segment to match. Then we're going to express each measurement as an equivalent mixed number. So our first one here, we have 2 6/10 centimeters. So we're going to use our ruler, and we're going to make sure that you're looking at the centimeter side. Okay. So remember that depending on your ruler, watch for where the 0 is. In this case, my ruler, the 0 is at the end. So what I'm going to do, keeping my ruler still, I'm going to draw a line. Okay, and you can see so far I've gone to 2. Okay, well now I need to go 6/10. Now the large line in between the 2 and the 3 is 2 5/10. So I'm going to use a little tick mark that's right past that. Okay, and so now you can see that I have a line that is 2 6/10 centimeters. Okay, so I could write it as a decimal and then as a mixed number. Okay, and now we do the same thing for our letter B. We have 3 4/10. Okay, so we start our 0. Okay, we get ourselves to 3. Okay, and then we can count 4 tick marks. Okay, and again, we know that that large line in the middle is 5/10, so we're going to be 1 tick mark to the left of that. Okay, so we have 3 4/10 centimeters. Okay, as a decimal and mixed number. Okay, in the letter C, we have 3 7/10. Okay. So there's 3, and then we can count 7/10. Okay. Now you can see letter C is just a little bit longer than letter B. Okay, by 3/10 of a centimeter. Okay, letter G, we have 4 2/10, so we're going to start at 0, and we can go out to the 4, and then we just go 2 little tick marks past the 4. Okay, to get our 4 2/10 centimeters. Okay, last one, we have 2 5/10 centimeters. Okay, so again, we go to the 2. Now in this case, it's nice and easy because we're just going to stop at that big line in the middle. Okay, representing the 5/10. So we have 2 5/10 centimeters. Okay, as a decimal and mixed numbers. Okay, so now we're done with the ruler for this. Okay, for this next part, we're going to look at doing some shading. Okay, so we're going to write the following as equivalent decimals. Then we're going to model and rename the number as shown below. So you can see the first one's been started for us here a little bit. So we have 2 1s and 6/10. Okay, so we're going to shade in. Okay, 2 1s. Okay, so 2 full squares. All right, and then we want 6/10, so we can count just 6 more tenths after that. Okay, so you'd have your 2 6/10 looking like this. Okay, and then we write it as a decimal underneath. Okay, and we're going to be writing this equation underneath each of these. Okay, so if we take a look at the next page here, we have letter letter B. So we have 4 1s and 2/10. Okay, so again, we're going to shade that in. Okay, so we're going to be shading in 4 1s. Okay, 4 large rectangles. To look like that. So there's our 4 1s, and then our 2/10 is just going to be 2 pieces over there. Okay, so there's our 4 2/10. All right, so now written as a fraction, a mixed number, we have 4 2/10, which equals 4 plus 2/10. Okay, we switch the fraction to the decimal, and we get 4 2/10 written like that. Okay. All right, next one. Notice how this one now we're starting with the mixed number. So we have 3 4/10 as our mixed number. So now we're going to shade in 3 holes, 3 1s, and then 4/10. Okay. So we have 3 plus 4 tenths. Okay, and then we convert our fraction into a decimal to get 3 and 4 tenths written as a decimal. Okay, so we have our 3 ones and then our 4 tenths. Okay, moving on to letter D. Okay, so we have 2 and 5 tenths. Okay, so we have 2 and 5 tenths. Okay, so we're going to shade in 2 holes, okay, or 2 ones. All right, then we shade in 5 more tenths after that. Okay, so 2 and 5 tenths, so 2 plus 5 tenths. We convert to the decimal, and we get 2 and 5 tenths written as a decimal. Now, we have a new question here. How much more is needed to get to 5? Okay, so if we look at what we don't have shaded, well, we have 2 full ones that are not shaded. Okay, then we go to this middle box here, and we have 1, 2, 3, 4, 5 tenths not shaded. Okay, so we need 2 and 5 tenths more to get to 5. Okay, so we actually have half of our boxes shaded in. All right, so now our next one, we have 37 tenths. All right, so now we have an improper fraction that we're going to convert into a mixed number. Okay, so we have 3 and 7 tenths. Okay, so now we can come over here. I'm going to shade in 10, 20, and then there's 30. So there's our 30 tenths, or our 3 ones, and then we're going to shade in 7 more tenths. Okay, so we have 3 plus 7 tenths. Converted into our decimal, we get 3 and 7 tenths. Okay, now again, how much more is needed to get to 5? So we just look at what's not shaded in. So we have 1 full hole not shaded in, and then we have 3 tenths not shaded in over there. So 3 and 7 tenths is shaded. We need 1 and 3 tenths to get to 5. Okay, so go ahead and give the exit ticket a try.